What's up? This is Madan here, and I will say, I'm here with another topic from aldehyde, ketones, and carboxylic acid. And what this topic is, actually, I'm about to introduce you about the carboxylic acid because so far we have done those aldehyde and ketones. So if you remember the very last video, that was from Cannizzaro reaction. But this is right after the Cannizzaro reaction, so I need to introduce you with the carboxylic acid. So this is going to be a short one, so you just need to stay till the end of the video and you will be knowing some facts. Though this is not very important for the examination point of view, but there are still, you cannot guess, what's going to be in your exam and what's not, right? So let's talk about the introduction and nomenclature and the structure of the carboxylic group. So what we have here is the topic, like I said, carboxylic acid. Carboxylic acid. The first thing I want to tell you is that a carboxylic group has been named as carboxylic because it has two functional groups. It has carbonyl, so carbo, and it has hydroxyl, so oxy, so carboxy, right? So it consists of carbonyl group plus hydroxy group right? And so it's called carboxy. There are two words here, carboxy, right? The second thing is that this is quite a very common chemical in our nature. There's so many things around us that we see in our day-to-day life, we use it in our day-to-day life, and these are nothing but a source of carboxylic acid. Now the question is, why we need to study, why we need to talk about the carboxylic acid? Because it is starting material of many very important organic compounds. Very important organic compounds. Now what are these compounds? You have amides here. So amides are also prepared using carboxylic. You have acid chloride. And you have ester, which is very common. Ester, something you've been studying for last 2-3 years, starting from your 10th standard. What ester is? Ester is a fruity smell compound obtained by the reaction between alcohol and carboxylic acid in presence of small amount of acid. So ester, and then maybe etc. So I hardly remember that. So many of day-to-day compounds are prepared using the carboxylic acid. Now the question is, what is the naming procedure? So the third important thing I'm talking is common name. You know what? The common names has a suffix, and it's called ic acid. For example, acetic acid. So what you see? Ic acid. Now, another thing is that most of the carboxylic acid are obtained, from some natural sources, and based on the sources they are being obtained from, they have been named. For example, this very acetic acid is called acetic acid, because it is present in vinegar. So it was first obtained from vinegar. So what is its source? Vinegar. So source is vinegar. Second, I remember, is a acid called butyric acid. So again it has ic acid, and this ic acid come from butyrum, which is present in butter. Actually, butyrum is a Greek word. Butyrum is a Greek word and which basically means butter. So from butter, butyric acid is obtained. Let me give you one more example. Formic acid. So formic acid. Formic acid, again you have ic acid. So this comes from, red ant sting. Red ant sting. Red ant sting. And that's why it has been called formic acid. So I don't know how you feel about all these very minor things, but these are actually mentioned in your NCERT book. You cannot ignore, because each and every line you have, something that may be a question in your exam. So that's why I'm paying, I'm paying even these topics, a bit of importance. Okay, so common name I'm explained. Now I need to talk about the IUPAC name. So what I will do, I will take some example and then I will, try to make it go. But before that, I want to, take the structure part here, right? So let me wipe this off and take you through the structure part here. Structure. A carboxylic acid has a structure something like this. A structure something like this. This. And of course, if you can see, the hybridization is coming out to be sp2. The hybridization is, so hybridization is sp2. Let's talk about the geometry of the molecule. Geometry. Based on the hybridization, you can say it's trigonal, planar. What does it mean? Each of these bond pairs have been isolated by 20-degree angle. So the bond angle is 120 degree. Another important thing is that reactivity. It is polar but less than carbonyl. Less than carbonyl group. Now let me explain you why carboxylic group is less polar than carbonyl group. It's because hydroxide group has also its own polarity. Hydroxide group is having its own polarity, which actually decreases the polarity produced between the carbon and oxygen in the double bond. So due to the presence of hydroxyl group in carboxylic group, it is polar but slightly less polar than the carbonyl group itself, right? Now what next I have, let me write it here. I am talking about resonance structure. Resonance structure. What this resonance structure is? Because the bond is polar, and like you see, there are lone pair on the oxygen. So what happened? This undergo polarization towards the oxygen, and in that case this lone pair utilized in making a pi bond. So therefore you get a single bond oxygen with 3 lone pair and a negative charge, and you get a double bond oxygen with a positive charge and hydrogen and with only 1 pair of electron as lone pair, right? So it is also stable. What that mean? It is quite stable also due to the resonance effect. Now I am taking one more very important topic, and that is the IUPAC naming of the carboxylic group. Though I have done in the second lecture of this chapter, but this might be this is what called reminding you how you can do the IUPAC naming of carboxylic acid, right? So what I will do, I will randomly take some example from NCERT and then I will solve it. So this video might pause here for some minute. Okay, so what I have done here, I've taken some question from NCERT on a random basis from the in-text part, and what I will do, I will try to help you out doing the IUPAC naming here, right? So let's start with the first one. First one, if you remember, I have told you that while you do the IUPAC naming, don't pay attention to the hydrogen. Just concentrate on the carbon and the functional group. So what I will do, in order to make you understand in a very simple way, I'm concentrating right over the carbon, carbon and carbon. So I'm placing 3 carbon, 1, 2, 3. Sorry, I need more space. So there are 3 carbon, 1, 2, 3. However, the third carbon is as a carboxylic acid, but the first one is also associated with the phenyl. So what this phenyl is? This is a benzene molecule. This is a benzene molecule. So let's do the naming part. As you can see, this carbon, this carbon chain has a functional group. So because it has a functional group, so this will be considered as a parent chain. This will be considered as a parent chain. This cannot be because it doesn't have any functional group. So this will be called 1, 2, 3. So what we see, this will be going to, this will go as 3 phenyl and propanoic acid. 3 phenyl propanoic acid, right? So if benzene is not having any functional group, this become a phenyl group. Let me repeat, if this was having a functional group, this could have been used as a parent chain, but this is because without any functional group, so this is used as a phenyl. So that's why the name become 3 phenyl, because it's on the third carbon, 3 phenyl propanoic acid. Okay, let's talk about this second one. As you can see, there are 1, 2, 3 carbon here. So I'm placing those 3 carbon. 1, 2, 3. But in the second and third carbon, you have a double bond. And on the first one, you have 2 methyl groups. So I'm placing those 2 methyl group like that. So these are the 2 methyl group. Right? So one of them will be a chain. One of them will be considered as a chain. And the first one from the right side has a carboxylic group. So this will be, parent chain. This will be a parent chain. So this will be 1, 2, 3 and 4. So what is going to be? This is going to be 3 methyl and 1, 2, 3, 4 butane, 3 methyl butane, but 2n, n is coming for the double bond here, and 1 oic acid, 1 oic acid. Right? Now let's do this third one. The third one has something new for you. The carboxylic group is not as a part of the this ring. So first thing, this ring is called cyclohexane because it has 6 carbon, 1, 2, 3, 4, 5 and 6. So this is cyclohexane, but you have to number it 1, 2. Why I'm starting from carboxylic? Because if you remember the priority series of functional group, this is the king of all the functional groups. So what that means? Everything starts from this functional group. So you have to number all others starting from the carboxylic. So this is going to be 2 methyl cyclohexane carboxylic acid. Cyclohexane carboxylic acid. So if carboxylic acid is out of a ring, this will be absolutely taken as carboxylic acid. If there was one more carboxylic acid, suppose there was one more carboxylic acid here, so this could have been dicarboxylic acid. So I'm not taking that. You can do on your own. You have to start the numbering back again. So this will be like cyclohexane dicarboxylic acid. But because it's not, so this will keep on, as it is here. Let's do the fourth one, sorry. So what this fourth one is, this is a benzene here, right? And as you can see, you have carboxylic here, and there are two ways you can do. You can numbering. You have two options. First, you can go clockwise. clockwise, or you can go anti-clockwise. Anti-clockwise. What this clockwise and anti-clockwise means here is that we can start the numbering in this direction, or we can also start the numbering in this direction. So let's see here. In the clockwise, 1, 2, 4, 6. 1, 2, 4, 6. So it's 1 plus 2 plus 4 plus 6. This is coming out to be 13. Coming out to be 13 here. And in anti-clockwise, let's count here. 1, 2, 4 and 6. 1, 2, 4 and 6. So in both direction it is only 13. So 1 plus 2 plus 4 plus 6. So both are 13. So what it means here, there was a rule, lowest sum rule. What lowest sum rule is? If clockwise was less than, the sum of the position of the functional group was coming out to be less than the anti-clockwise, we would prefer clockwise. So whichever is going to be the least one, we will follow that. But right here, both are equal, so we can follow any direction. We can follow any direction. Another reason we can follow any direction is that, other functional groups are only nitro. So there is no alphabetical issue as well. So what this is going to be? This is going to be, 2, 4, 6 trinitro. This is going to be 2, 4, 6 trinitro benzoic acid. Benzoic acid. Right? So this is how you can, do some nomenclature part as well. Let me be sides here so that if you need a screenshot, you can take. Okay, now what I wish to say that this was an introductory video for carboxylic group. What I will do, in the next section, in the next lecture is I will talk about the preparation of the carboxylic acid, and there are some really very serious and very important, chemical equation with some mechanism. So this might be, something you already knew, or it was a bit interesting but not that much important, but the coming lecture again is going to be very important. Another thing I wish to say is that this chapter is in its last phase, so pay attention, because the last section is carboxylic acid, which is one of the very important topic from the examination point of view. Doesn't matter if you are working hard for your competitive exam or for your board exam, right? So I'll say thanks for watching, and don't forget to subscribe in case you haven't. This is the first time I'm saying probably. Don't forget to subscribe, and if you like my work, one thing you can do, you can share with your friends, you can share with your family friends, you can share with your friends, your schoolmates and all, and everybody else, those who can be benefited here. And the motive is to make you understand, make you go slightly different than what you are trying to do, right? That's it. Thanks for watching and take care.